Thank you, Green. Before the lecture, I'd like to say many thanks to the supporting team led by Sarah, like Helen, Leslie, Steve, or whatever. Without them, I don't think the presentation will be coming out tonight because they helped me to check my English and presentation, even background rehearsal, whatever. Right, so the topic is quite straightforward, modeling control. Only one word debatable is the philosophy. I'm not very good in English understanding, but I try my imagination, see if the word's still true or not after the lecture. We go to next page. This is being used for overseas presentation, but tonight is not a test or quiz for the other part, left-hand side of the map. You know where it is, and we don't have to say the difference between UK and GB. But anyway, I still say something proud of to be the citizen in Bristol. Shape in Bristol is always my philosophy. And of course, the member of staff here, the student at UE University, whatever, the best, right? And then the purpose of the lecture, Glenn already clearly explained the wide sense about the public lecture. But for myself, the narrow sense about the purpose of lecture, I have several questions here. First one, my research. Although I have many colleagues been here for many years, probably they don't know what I have been doing, what I have achieved. And secondly, how's my research important to professional or applications studies? And then what I have achieved, mainly through my publication and research collaborations. And the last one is about the methodology or results useful for something else. And we have several colleagues from interdisciplinary subject, and hopefully it's a promotion, and we work together afterwards. And then the presentation outline. When we talk about modeling and control, people immediately move the imagination to mathematical equations, stability analysis, Ross criterion, whatever, and then a lot of equations. But what I think in this presentation, I have titled into audience-oriented. About this presentation, I am going to use a layman's language, try as soon as possible, and also I simplified my English as well, because I haven't learned too much complicated, subtle English, so I use a plain English. Right? And the talk actually divided into two parts, general talk and the specialized talk. General talk attract you, make you feel fun of the topic, useful, and then you can make your imagination a good dream tonight. And specialized talk is about my research, and talk about a little bit more my current result or achievement and something else. We talk about some hypotheses, assuming your philosophy or whatever, you have some hypotheses. Modeling control methodology exists in various natural and man-made systems. Natural systems like a weather, man-made systems like a machine or robot or any cars, airplanes. And the principle actually exists almost everywhere. You know or not, but exists. The principle applied to our life, the work, economics, and politics. So this will be reflected in my general talk. And then I'm going to use the principle to tell my research, which embedded modeling control as well. And afterwards, we still have about 20 to 30 minutes for question time. You may ask me, so I couldn't find any example around me without modeling and control. So let's have a debate and PK who's winner, right? So before talking any control or modeling terms, we need some basic understanding about some basic concept, and then we can easily go through the demand, understand even social life or business studies or whatever. System could be anything, car manufacturing system, even the management system, the university operation system. It could be generically called system. Even our educational departmental organization could be the system. How to collect the system information or behavior? We need two sort of information. One is called numerical information, which we use the instrument to measure it like 1, 2, 3, 4, 5 in number. And also we have other way to measure the system performance and know it better from expert linguistic information. Where is it coming from? From questionnaire, from talk, from interview, from document. So I gave 1 or 2 examples here. Like our human, ourselves, we have some information can be measured by instrument. Temperature, blood pressure, and other things we use instrument. But what about personality? We have to use expert to evaluate. So actually for human body or human being, we have 2 sorts of information. And the other example is running a car. When you set in car, you can have speed, position, acceleration to be measured by a transducer machine. But what about comfortableness? You can't measure comfortableness by instrument, but certainly the information exists by human feedback. So this is the information exists in the system, numerical and linguistic. But we must be careful, some information not very accurate, like human words, like gossip, and something they make rumors. It's not very accurate, noise contaminated. So when you process something, you believe or not, you need to take care. So this is error in data. And then go to the system. We talk signals exist, information exists in the system already. And what about move the system into the direction which we are looking for? We need several blocks. The system, we can treat it as a black box because inside it's difficult to understand, particularly for complicated systems like a global economic system, urban transportation system, too many variables, too complicated interconnections. So what we know is outside or external relationship from input, output. You put some contribution, investment, how the system improve. So what we can measure from input, output. But for understand or summarize the system behavior, we need a model. So the model actually is a part of wetland or change the color into gray box, which means the information more or less summarized instead of just lengthy pages, lengthy papers to descriptions. And then the control more like a police or traffic warden to manipulate operation, give light to go or to stop. This is called performance improve. So control functions is a sort of operation of decision makers or decision making. And to obtain the model, it's called model training or identification from data. So each time nowadays we are facing a lot of data processing, the data mining or data explosion problem. So we need a proper approach. And now we go to the general talk. I'm making you laughing. If you not laugh, it's my duty, right? Modeling almost everywhere. So the first model I must tell because I benefit from here is job interview. YT is the result. YT minus 1 is the performance, your CV. And the B is the interview performance. So put together is a weight, right? So I submitted my CV 10 years ago, a decade ago. And then I went to, or invited to UW for a job interview. And the 2 panel members, as Glenn said, decade ago supported me, and tonight coming to support me again. So you know who they are. I don't have to mention their name for confidential or whatever security things. But they decided A and B. So finally I got a job. This is the job interview model. And then buying property. Last year's property, the rate increase, decrease, and some uncertainties. But I don't know if we buy property when the price down or showing up, it's debatable. But I just tell you the model here. And this principle, my old friends know we had a common habit buying properties or whatever. So we exercise mathematical modelings and get our life as well. Then This is another use for salary, family life. Big potatoes, smaller potatoes, your salary weight, you take 50,000, you take 10,000. It depends on your rank. Yeah, so this is a mathematical model. And also the model can be used as a family planning. How much invested for holiday, how much invested for business property, or how much invested for your retirement. So this is a model for your reference. You will have, although I'm not mentioning somewhere else, you still feel exists already. So no much more mathematical proof, but it's just in what's called instinction or intuition that you know. And this one, without mathematical model, but the model exists as well. A person from birth to death. I just take myself as an example. When I was born, I didn't know who's my mom, but only a few hours. I have no mathematical model. I couldn't speak, but I can know who's my mom. When I want my mom feed me, I feel hungry, I cry. This is my signal. I have no equation, no PID controller, but I can call my mom easily for milk. Right? I survive. One day, I talk myself, this is not good words. I go to hospital, get a medical report, say, oh, you got a problem. You won't be here long. So I must go back, rush home, prepare my will, pass money, properties to my daughter, and run everything, and then I go away easily, comfortably. So when you die, this is another model from medical report, tell you something. This is a reference. As many youngsters here tonight, so I thought probably it's useful for youngsters, but certainly not for old folks. For example, in pub, a boy like a girl, you may model if the girl can go with you or not tonight. You say, are you fancy for drink? Girl said, wait for a while, I need to call my mom. And then you think, oh, sorry, I have no drama tonight. This is the model as well. No mathematical model, but intuition or the feeling will tell you to summarize the personality, the potential you're going to do. So mathematical model is not always there because simply the word is not described completely by mathematical model, even by some experience. So this is why I said don't look down managers. They're not making mathematical equations, but they are the best modeler controllers. In their mind, they use very complicated logic to organize models, how they can lead department, faculty. For engineers, you use the equations, you easily manipulate because that's a man-made machine. It's not human. So this gave us another indication, probably my senior colleague or manager is happy about it. You are very important to us. Oh, sorry. Let's go to the second concept, control. Control also exists everywhere. So this target you want, and this existing entity or property or equipment or whatever, what sort of extra effort you're going to contribute to get your target. For example, many students here, you want to get your degree, what you exist, you have your own, you pass the exam with entrance A-level, whatever. What extra effort you put on? You put on your money, you put in your time, you study hard. If you can pass, we set up 60% here to pass. If you don't pass, you fail. You have to study again. So this is a process. We use a very important concept called feedback. Feedback in business concept is a review. Everything is review. You review the process, and then you decide what we are going to further improve. Actually, every day, many of our colleagues, friends, and students doing review, feedback, change, adjust. So you are the master already in modeling and control. Actually, I'm not sure if I'm really necessary to talking anymore about modeling and control, but I still keep it on, even though probably make you a little bit boring. So control give you a lot of things to do. You do everything, even control your wife, yeah? Control your husband, control your family. You control, you set target, you adjust it, and then you get a result. So control gave us a way, particularly make people wise, is the feedback. Otherwise, if like my dog, you're just running without any review, probably something gone bust someday. My research, modeling and control. As a sort of academic people, you set up yourself you always think you have two ways. One way, I must have some theory. I must have some methodology. It's called Quan theory. It's best. And then how I can use the theory to direct or guide applications, to test, to validate my result. So I use the analogy is creating or developing methodologies more like a sharp knives. If you have sharp knives, application more like a meat. You cut a meat, use knife to cut meat. So I claim myself into several directions. One is, as Green commented, nonlinear dynamic rational model identification and control. Secondly, neural fuzzy intelligent approach. And thirdly, very funny imagination for meridian system modeling or electrical stimulations. I will talk in a few minutes about application. But for methodology, I'm just picking up two examples here, let you know it's some funny idea or maybe clever idea. Rational model identification validation and U-model-based nonlinear control system design. I'm sorry, I have to change my English into English mathematics language. So in next 2 or 3 pages, I'm using a little bit math, tell you the background. You just think, oh, this is the story taught by mathematics or mathematician. Rational model, you just take let's a simple ABC, it's a sort of function. And the merit or the miracle point of the rational model is the introduction of the denominator. The denominator created a lot of benefit, consciousness, but also brings some trouble or challenging to deal with. So that was my postdoc research fellow work in Sheffield about 5 years. With that, just this model, I survived 5 years. And the UK's 10-year salary from Queen and happily set up my permanent residency just from that equation. See what the equation is. This example talk about consciousness. This rational model, if we use a polynomial, use a Taylor expansion, you can say you will have hundreds of thousands of terms to approximate if you want to reduce the error. But just 2, you got it. And then the second example is here. UT could be a very critical parameters, earthquake or something gone bust. But before that, they will give you some indication. The energy suddenly go up. Environmental things change or medical situation. And this, if you use a polynomial, you need a lot of terms to approximate. But rational only use a critical model to indicate something else. So this is a merit, but not always good. We are looking at the trouble on next page. So here, again, mathematically, the error, if you want to identify the parameters of the model, you will have some correlated error. So this is the big trouble or challenge. And people realize the problem spent about 5 years with Steve Billings' group in Sheffield, but they didn't get answer. And then I was recruited. I spent about 2 or 3 years from the initial idea. It's just an overnight dream, and then suddenly I had what's called intuition. I found the solution quickly, and then about a dozen papers published in high-level journals, particularly International Journal of Control. Right? Model validation. If I tell you the story, you will say this is just a mathematical language. Model validation actually is to check if the model error belongs to the model. If the model error belongs to the model, means the model is not accurate. If the error is independent of model, the model is accurate. So this is a mathematical language. It will tell you if the error associated with model or not. This is more like a, what's called liar tester. Test lions, they will test the signal, see the things right or not. And this is the second knife I have sharpened for many years, and the result published by IMAC-E, IET, and I have many fans to follow this direction. They've been promoted to professor already in other countries. They still keep asking for programs, but I said, you pay money, I gave you, otherwise you develop yourself. This model actually presents another idea. If you are special people in control domain, we use a piecewise linearization. This gives you an approach to design linear system, but piecewise introduce some errors. But my approach is pointwise. Point by point, you can use a linear principle, which you will develop to design the control system point by point. So this gives you a freedom. The model in nature is time varying. So this is the other miracle point. I think is my cleverness to make me or drive me to develop because I'm interested. And recently, we tried to use this one for some industrial project, particularly for smart building control system design. When nonlinear coming out, this could be significantly reduce the cost and also the programming difficulty. Right? This is the meat I have cut already. I have several projects, just as an example, pick it up. Incomplete data interpolation, impact detection, neural network things, and the safety level assessment. And the last one is the intelligent acupuncture instrumentation. This example gives you a very much background, like any data loss. For example, instrumentation in operation, you have some accident, the signal lost. I didn't check if UK stock market has share price during Saturday or Sunday. If we don't have the data, this can help you from the existing data to recover the lost data. Any interruption, the data loss, how we can recover? We're going to use the data before or after we recover the lost point. So I developed some spectrum analysis approach in work with Professor John Dawes, who was the IWE chairman in Control Society about 2 decades ago. Then this one is much more applicable to Airbus because the wing is a composite material at the moment. The big trouble is the impact. After impact, the delamination coming, you can't see it by eyesight. But we can use the signal measured like a smart material, some sensors inside to tell where the impact, when the impact, how severity of the impact. 3 questions: point, location, severity, and time. So we have worked with Cranfield University for a few years on Airbus as a background storage, processing data, use a neural network. We had some paper published, but unfortunately, we didn't get a grant. We studied, we exercised, take the data, but finally we didn't get industrial support. The pity thing. This is another PhD project. This could be used as a helicopter. This go up is a hooving, stable or unstable. PhD work in some sense. We tried some intelligent approach. So the PhD student did about 10 years with Chris Meyer-Hughes and Tony Pipe in his robotic lab, and we make the paper published by IEEE neural network. So the result is quite promising. This is more like a brain training. We did use the equipment or rack in lab, but we didn't put into real things. But this still leave a potential. If some colleagues in the future to do some similar study, we still have materials available to provide. This is the safety level assessment, which was a British rail company based in Bristol. We visited them, we had a discussion, they provide some background. You can see number of things related at the input to contribute to the SPAD, signal path at danger. So the output will assess the level of dangers. This depends on driver's age and the weather, and also which day coming back to work, and also experience. So at the moment, we have done several rounds of undergraduate, postgraduate projects. We only use 2 input. experience, and also the weather condition. What the future could be is a future for insurance company. How the insurance for each individual driver, instead of just a one-level driver, it's more like individual insurance. Also for company to plan their shift work, particularly Monday morning, don't let some youngsters to drive locomotive. It's more dangerous because they just come back from weekend, probably drank too much. So this is some indication reference for the managers to decide. I don't know how this one principle can be applied to our faculty or departmental management. If people are in sad mood or in some depression situation, don't ask them to do much more job because probably no good for the faculty. Acupuncture. Acupuncture is my dream because I came from the acupuncture country. No, to be honest, no much scientific evidence. This is why acupuncture or Chinese medicine not very popular in Western country. We must be honest. The reason, my understanding is no enough scientific eyes to look at the signal, evidence. People just mouth by mouth to pass experience, not scientific evidence-based scientific study. So almost, as I said, just by experience. Master tell disciplines and tell students and then pass. So what we've been doing about a decade ago, we developed some sensor to measure human bio-resistance. And then we pass the information to computer to process, and then by acupuncture, we try to invasive, means not injecting into the body because people scare the needle into the body. So we try to use the TENS, but what we try to find is the sensor point. I believe on our body there are some sensor point. Like a temperature in this room, if you put a dot over there, the sensor probably not really reflect the room temperature. You must put it in the proper place. So sensor point will give us a chance to tell very accurate or easy or comfortable place to inject the energy in. So acupuncture, in other way, can be treated as a physical therapy. Chemical can treat us, take tablets, electrical, mechanical massage, you can get an effect as well. So this is my dream. Sometimes I even think about to help people, if they depressed, I gave him a happy current, change his mood. If he is too excited like me tonight, couldn't sleep, I may need a calm down current. So this tells us something about the position to inject the energy, and also the stimulation amplitude, the frequency, and the time duration, what you're going to put it on. So this leaves us a lot of, I think, like acupuncture engineering or biophysics things, how to build up instruments, scientific eyes to measure some phenomenon. I can give you another example, like in Western medicine, we use what's called cut body. It's called yes, cut body to find nerves, whatever. But when you cut body, you couldn't find the acupoints. My debate is like a radio. When radio died, you cut off, you couldn't see any radio wave because the body died. The existence of the meridian system actually is a sort of biosystem. Certainly, we are working in some way. Because otherwise, like 1.5 billion people won't use acupuncture in daily health service. And the other things at the moment, WHO already officially recommended acupuncture to be used in Western society. Even in Bristol hospital, you can find some acupuncturists already. But it still needs a lot of research. We are the scientific research people. We need some evidence. So for engineering job, it's how to build up instrument. Not very difficult, but it's how the concept develops. So this is why I talked with Jenny several times. And I will show you a current PhD project we are planning at the moment. That's a current project. The first one, I thanked my student Sanjeev Sama. Actually, he's a very senior member already. I shouldn't call my PhD, but he only needs a PhD. He has everything else. And he's the manager, whatever, help us to visit Airbus many times. Each year, I take my PhD MSc student to Airbus for experience, and Sajid is the coordinator over there. And he's nearly finished his PhD, and final submission will be next month, I guess. Yeah. And this one is another environmental issue for wind farm. We generate sustainable or reusable energy with traditional or whatever H infinity control, robust control, because this must do something in control. Otherwise, the turbine or the wind farm is not easily controlled. Disturbance uncertainty is severely witnessed here. So that's my student from China. He used to be UW MSc student. After 5 years in Siemens, he fed up. He said, I must come back to UV. And 2 years ago, he come back and supported by his family. This local boy, James Furley, he's here tonight as well. You can see my principles applied even to general health subject. The plant actually is a sort of environmental sensor. The plant change or distribution with the evolution and climate. If the climate polluted, how about the plant shape change? So James trying to summarize human experience, bridging numerical data and expertise into physiological-based modeling characterization. And James just been here for a year and published 2 papers looking for Royal Society grant as well, and we're going to submit before January. The smaller one, but it's an indication we are bidding. This is for smart building. We try to use, thanks for Janice from ANET support, we are developing some idea. The demonstration program actually is available for real tests. If they can provide building parameters, PID control system can be easily set up. Save tremendous time finding the combinations, could be 1,000, 2,000 combinations for 3 parameters. But here, maybe once through, you can get a direction. Like where's the goal in that direction, you don't have to dig somewhere else. So this is very good program developed. And also we developed some animation like virtual reality background, give customer real feeling for smart building control. All right, the project of my philosophy not only rooted here, also in China we got some flowers as well, or fruit. Because Chinese people learned from my lecture field modeling control very important, and then they send 3 PhD students to here. They pay us tuition fee as well. Part-time PhD, the first one, you can see this pipeline robot is useful for inspection or maybe some extra work inside pipeline, which is human being very difficult to squeeze in the smaller pipelines. And she's a visiting student here as well for a year and sponsored by Chinese government. Then this one is my dream. I'm working with Janice. We jointly supervise electrical magnetic effect for sensory of human body. So the students are very good in mathematics and also with bioinstrumentation background. They got equipment in China they are developing. He's coming in June next year for 1 month visit study. Then this environmental issue again, because environmental issue very, very important in China. They try to use a sewage system and how use some control system to adjust the chemicals and change the treatment system efficiently and reduce some pollutions. This one actually is for pharmaceutical system. The lady working in pharmaceutical company, her company asked her to develop some control or modeling approach. And she approached me in last year's international conference, like to study and pursue UW degree. She got a master's degree in Australia already, and Alistair interviewed her over phone about 1 month ago, Alistair? Yeah, we interviewed her over phone, yeah. So she offered a PhD and you signed. Right? I won't talk too much. Conclusion, I think my purpose to explain the basic control concept should be okay, because from feedback, I talk about feedback, your eyeballs smiling cheerful, so I feel it's good. Actually, you understand what I'm talking about. So, and also I think more or less you agree, control is not specialized subject. I'm not electrical engineer, I'm not mechanical engineer. But I'm the calculator, work for you. You can use me to calculate, even calculate your water bill, electricity bill, modeling, smart building, plant, whatever, as you like. I'm not sure the word philosophy is still good or not, because there are many native speakers. You can help me to correct and give me a proper definition how I can define my subject area. And you benefit? I think so, because more or less you may talk about modeling control, and Ashley is my senior and English teacher as well. So I think this one could be used for a student. I think you will have more courage to learn the subject. Each year when we talk control, people feel headache. Oh, too much mathematics. Oh, I don't like it. I'm scared. And students even asked me before the project, said, you're a mathematician. I said, no. I said, you come to my lecture for a few times, you'll be okay. So this is why I prepared the lecture handouts or this evening's lecture a little bit easy for students to have a courage to follow. Actually, my approach to present control and modeling already received well response from students for many years. Each year, if you can say check the student feedback form, they gave me very good complimentary comments. Say, oh, Quan, you made us. And also I provided 3-year guarantee for the product I taught as a charge-free. Anytime for control problem, call me back. So students very happy, say, we like UW staff with such a warranty for 3 years without any charge. But of course, after 4 years, they pay big sum. But if his company doesn't give, I must ask his parents to pay. Modeling control for collaboration, actually I have generated some collaborations already, with particularly Janice and Patrick from building side, yeah. And also Ashley being my English teacher and collaborators, and also the concept of collaboration for China. Steve, I must say the name, Steve and Alan, we work with China many, many years. We use the modeling control, drive UW work quite well. We had a 3-year golden time, European funding, over a dozen MSc students to ATE, and staff exchange teaching program, whatever. So anyway, finally for myself, I used methodology, found a job, happily survived in Bristol, and friends, and you can see tonight, people coming from Professor Wang from work about 100 miles away, and Steve canceled his very important meeting in London and coming, and you know, so many support, and my current boss, even he doesn't know anything about modeling control, he patiently sitting over there. So I also built up my family. I didn't use my skill in pub fencing Junkao with my wife, but I modeling her the first day he arrived in Manchester airport in the coach. I modeled she's my wife, so, and then I built a family with lovely daughter as well. So hopefully my lecture gave you a concept, you're happy, you're loving, you feel useful, and you are the master already. Thank you.